can see that. So write 0.3 as a fraction, so instantly your answer will involve a number on the top and on the bottom, numerator, denominator, and we can see that 3 is in the tenths column. I'm saying that slowly on purpose. So it's not tens, it's tenths, which means we know the denominator is 10, and the number that's in the tenths column is 3, so we just put that as a numerator. Work out 3 squared, which means 3 times 3, which is 9. This is like order of operations or BODMAS. 3 plus 2 is in a bracket, so we do that first. And then I will write out the question again, which will make it easier to do this division. 20 divided by 5, 5, 10, 15, 20. So 4 times. 20 divided by 5 is 4. Write down a factor of 60 that is between 8 and 14. So I'm immediately going to list all the factors, not worrying too much about this between 8 and 14 just yet. We can just come back to that in a second. So we know 1 times 60 is 62. Okay, so we listed out all the factors, and we know 7 doesn't go into 60, it's not in the times tables for 7. 8 isn't, 9 isn't, 10 is, but I'm not going to write that because I already have 10 over there. So that tells me I've completed my set. And now we can say which are the ones between 8 and 14. Well, I only need to pick one, write down a factor. So I'm just going to pick the one that I like the most, and I'm going to pick the 10. And you could have written 12 as well. But make sure you only answer with one of them. Okay. Question 5 is an algebra question. So we need to see what all the numbers are first. So algebra, we normally write the numbers first, and then convention is we write the letters in alphabetical order, and these letters just mean timesing by something that's representing W. We don't know what that number is, so we'll just keep it as W, and T. So alphabetically T would come first, and then W, and then we need to write a number before there, and that is the calculation 3 times 5, which is 15. You would still get the mark if you wrote 15 WT as well, but this is just convention to write algebraically in alphabetical order. Okay, number 6. This looks like a lot of writing, so my best tip here is kind of go straight to the final question. So what do we actually need to do here? And then that helps you read the question a lot better, because you kind of know what you need to look out for. So how much money does she have left? So working backwards, we know that Faye pays all of the costs for this trip, and she's got £200 to spend. So we know at the end of it we'll have to do some kind of calculation, which is 200 minus something equals our answer, which would be in pounds. So let's try and figure out what this something is. So we need to figure out all of the costs. So we know that there's 1 adult and 2 children, and there's different prices for tickets and meals, and there's only one price of petrol because that doesn't matter if you're a child or an adult. So we know that 23 is first up in our sum, so we're going to be adding. Then we need to see how much tickets cost for 1 adult and 2 children. So I know that 1 adult is 33, so I'm going to add 33. And it's 2 children, so I'm going to have £24.50 twice. 24.50. So we are adding with decimals, but that's okay. Still works. And don't forget the second time. And then we've got meals, so £15 for each adult. Well, there's only 1 adult, so we're going to add 15 once. And then there's 2 children, so £10 and £10 again. Just move that for a second. So let's start from the right hand side. So 0 plus 0 is just 0. 5 and 5 is 10. Put the decimal place exactly underneath where your decimal places are in the sum, and we're carrying a 1. And then let's add up our units. So 3, 6, 10, 14, 19, add the 1, don't forget that, is 20. And so I'm carrying a 2, 2, 5, 7, 9, 10, 11, 12, 13, 14. So I really did not leave enough space here, but I basically get £140 as my cost, so I'm going to put that straight in the box. Remember, this is not a calculator paper, so you kind of do need to show your working out. There's different ways to add here. For example, £24.50, I could have added that in my head and I would have got £49. So that might have been easier for me to add, and I won't have decimals, but I still get my answer of 140. Saying that really clear. But we're not done yet. So remember, this is why we wrote this calculation. I should have left a bit more room, but this is helpful because sometimes you just think the answer is 140 because you've done this big calculation and you just want to move on to the next question. But we need to stop and think about what that actual question is. So £200 is how much Faye has, and she pays the costs, which are 140. How much does she have left? That is just a subtraction, hopefully you can do in your heads, but it's £60. Okay, question 7. So there's 8 letters, we need to write down the mode. My favourite, average. So there's different averages, there's mode, median, mean, and the range. The mode is the easiest one, I think, because the meaning is kind of in the word. So mode sounds like most. So which is the most common letter? And you can see that A is, so we just need to write down A. One of the 8 letters is going to be picked at random. On the probability scale, mark with a cross the probability that this letter will be B. So the scale is this. We don't really need to worry about, all the different, how do I say this? We don't need to worry about what the different numbers go here. Sometimes you get questions asking you to fill in things, but we don't need to worry about that. We just need to put a cross on the place that the letter that they pick is B. So straight away we know that there's 8 letters overall. We could count them or we could just look at the question. And we need to see how many of them are B to get the probability for B. So we know that there's 1 and 2 B's. So that tells us that the probability is 2 out of 8 in total. And we can simplify that by halving the numerator and doing the same to the denominator to get a quarter. And a quarter is easier to put on a scale than 2 eighths. And a quarter just means it's halfway between 0 and a half, or it's a quarter of 1, so it would go here. And you can, if you want, put a quarter there. But you can see that a quarter is 1, 2, 3, 4 parts of the whole. So 1 at a quarter is this first bit. Okay, find the probability that this letter will be C. So this is similar to what we just did for B, but it's actually a bit easier because we don't need to plot anything. We know that there's 8 in total and there's only 1 C. So it's 1 over 8, so it's a smaller probability than B. Okay, algebra again, but this time it's an equation. So M is a number we don't know, but when I take away 3 from it, I get 4. So we kind of need to work backwards and think, what number, when I take away 3 from it, do I get 4? And we can probably work that out in our heads, but the way that it will work for any type of equation is you have to balance both sides. Your school or teacher might tell you a different way or a different term, but it all means the same thing. It means getting rid of things that are not M and having M on one side of the equation and a number on the right side of the equation. So what is happening to M? We know something's happening to it. It's being subtracted by 3. So we want to do the opposite of that, so the inverse. So we want to add 3, and everything we do to one side of the equals, we have to do to the other side of the equals. So I need to add 3 to both sides. So minus 3, add 3, we already know that's going to give me 0, that's why we added the 3 in the first place. So I could write m plus 0, but we know that doesn't really need to be written. So m on its own is what I need to write. And it's not 4, but we just bring down, we have to do something to it, we have to add 3 to that, and that is 7. So that's a longer way to get it, but the method is quite good to know, because in another question you might get a harder equation and you need to know what method to use. But in this case it was pretty easy that we could just do that in our heads. That's 7 take away 3 is 4. Okay, this is slightly different. We are not just adding something to our algebraic letter, which is n, we're timesing it by 3. So 3n just means 3 times n, or n times 3. And then we're adding n again to it. Again, we don't need to know what n is. We know what's happening to it though. So we need to collect like terms here. So when I say like terms, I mean this is a term and this is a term. So there's 2 terms on the left. 3n plus n, well, n here is actually just the same as 1n, and that gives me 4n. And I don't need to do anything to the right hand side like I did for part A, because I'm not actually getting rid of anything, I'm just simplifying it. And I'm not adding anything to the terms, I'm just simplifying the existing terms. Okay, so now we're saying that 4n equals 24. This is the same thing as saying 4 times something equals 24, and we need to work out what that something is. So again, you could work backwards. We know our times tables. We know this is 6. Okay, this is about finding the value of y, which is this angle here. And we kind of need to know the rules for angles. So we know that this is a point here. And we got something that looks a bit like a circle. Well, it is part of a circle. What is kind of tricking us is the 70-degree angle, the line, it could actually just be here. And that might ring a bell for people, because we know that our rules always show, you know, an example of this type of circle and what the angles in a circle add up to, or angles around a point is the correct term. And we know that that's 360. So knowing that, we can get the value of y. We have to do 360, take away 70, because that's the bit left that we want to find out. Y is the bit left. We know that this bit is 70, but altogether the whole circle is 360, but we don't want to know what the whole circle is. We just want to know what the y portion is, which is just this bit that I'm shading. So if you work that out, you get 290 degrees. Okay, give a reason for your angle, and you can simply write angles around a point add to 360 degrees. Okay, here are 2 triangles on a grid. Triangle B is an enlargement of triangle A. Write down the scale factor of the enlargement. Okay, so if we know that something's enlarged, we can kind of see it on the diagram. A was this triangle and B is an enlarged version of it. We need to see how much it's been enlarged by. So think of the camera zoom, right, on your phones. Is it 0.5? Is it 1 times, 2 times? What is it? And the way to do it is to pick a side from your original shape. So let's pick this side. That's 3 squares wide. And see how much that has now changed on your new shape, your enlarged shape. So it's 1, 2, 3, 4, 5, 6. So this side of A was 3, and it got enlarged to 6 squares. So 3 was enlarged to 6, and how did we get from 3 to 6? We're doing a multiplication here, we times by 2. So the scale factor is 2. So for part 2, we need to mark on this grid across where the centre of enlargement was, and that just means there's a point on this grid where the enlargement started from. So you basically need a ruler. I don't have one right now. I've got a coaster right next to me, and all you have to do is pick a point on triangle A and find the same point in triangle B and draw a line through those 2 points like this. Mine's going to be super sketch, by the way. Then do the same for all the other points. So this point in triangle A and this point in triangle B. And you want to draw it long enough for something to hit the other lines that you've already drawn, and that will basically show you what your centre point is. So that's the last line is only going to be 3 lines because there's only 3 points in this triangle, and where they all meet is your centre of enlargement. Oops, it's a cross, not a dot, but that basically helps you get the point. Here are 2 parallelograms on a coordinate grid. Parallelogram D is a reflection of parallelogram C. On the grid, draw the mirror line. So the tip here is you again pick a point, and what I like to do is just see how far apart are they from each other in terms of squares. So I've picked these 2 points, and that's 1, 2, 3, 4. And I basically just half that. So half of 4 is 2. And so I count 2 down, either from C or 2 up from D. And this is like where my line would be. And I can kind of do that for the other points and mark them with a little line here, then you draw the line properly. So let's do these points, and that's 1, 2. Well, half of 2 is 1, so count just 1, or 1 up, and it's there. And these 2 points, 1, 2, 3. That's a bit harder because we're going to half that to get 1.5. So you basically have 1.5. So that's somewhere there. Which point have we not done at this point? Count the squares from this point to this point. 1, 2, 3, 4, 5. Okay, harder than the even numbers. We're going to get 2.5. 1, 2, and then a half. And that makes sense because they're all basically in the same line that we're making. So again, I'm going to use my ruler to draw this line. So now part 2 of B is write down an equation of this mirror line. So this line has an equation. I'm just going to draw it a bit longer so it makes it really obvious. But you should see these lines all the time, kind of know off by heart if possible. But we call this line y equals x. And the reason to get, if you didn't know that, don't worry, you can work it out. You can basically ask yourself, you can pick at any point in the line you just drew. So let's pick this point, just randomly. What is the y coordinate? It's 2. And what is the x coordinate? It's also 2. So we can actually spot that as a pattern for all of them. Let's pick this one now. That is y equals 6 and x equals 6, which is the same thing as saying y equals x, 6 equals 6, 2 equals 2. So our equation is y equals x. Okay, question 12. Eleanor spent 120 minutes at a sports centre. She played badminton for 50 minutes. She used the swimming pool for 1/6 of the 120 minutes. She used the gym for 20% of the 120 minutes. She then spent the rest of the 120 minutes in the cafe. And naturally, you have to kind of do all this working out to get how much she spent in the cafe, which is what the question's asking. But it's worth 4 marks. And it basically wants us to use fractions, percentages of numbers to work out how many minutes is left. So we know the total amount is 120. Let's find out how much she spent playing badminton. Well, they've actually already told us that, so that's something that we don't need to worry about. So I'm just going to write this in a way that would make sense to me. We have 120 minutes, and badminton is one thing that she does. Then she does the swimming pool. Then she does the gym, which she might not do in this order, but that's the order we've given in the question. And then the rest is in the cafe, and that's kind of what we don't know yet, but we'll find out. So badminton is 50 minutes, so we can just write 50 there. I can write minutes, but just keep it as numbers for now. Then let's work out how many minutes was used, did she use in the swimming pool. A 6 of 120. We don't have a calculator, so we need to think about what this calculation really is. 1/6 of 120, that is the same thing as doing 1/6 times 120, or 120 divided by 6. And that might seem really hard because it's a big number, but the trick is, let's do 12 divided by 6, and then we kind of put the 0 on the answer. So it's not very scientific, but it's a quick way to get this answer. So 12 divided by 6 is 2, because 6 times 2 is 12. And you add the 0 to 20, and then always check, right? When you do this kind of trick, check that, does that make sense? Think about doing 6 times 20, how would you do that? Well, 6 times 2 is 12, and then you put the 0 in, and that makes sense. And we also know that 20 times 5 is 100, 20p's, 5 20p's, make a pound. That's my tip to always remember that. And if I add one more 20p, so I've got 6 20p's, I get £1.20, or 120p. So this should hopefully come quite easily. And we've got our answer of how many minutes, put that in there. Then the gym, this is using a percentage. Sorry, the battery died, so I just realised after I did the gym question, but I'll just go back over it. So for gym, this tricks people sometimes because we are so used to doing percentages of a number on a calculator because there's a percent button. But when you don't have a calculator for paper 1, you need to remember how to do this the original way, or the old way. So to get 20% of 120, you don't divide by 20%, or you don't divide by 20. That is a common mistake that people make. And I was going to basically write that out and show you why it's wrong, but we're running out of space. So basically the calculation to do this is you first find 10%, and to get 10% you divide by 10, and you can do that in your heads, but 120 divided by 10 is 12. Then we know that 10% is 12, but we don't want 10%, we want 20%, and the trick here is, how do I get from 10 to 20? I times by 2, so I must do the same to the other side, and that's why I do 12 times 2 is 24. So gym is 24 minutes. And that means that we can add all these up and take away 120 and get the remainder in the cafe. So 120 take away 50 is 70. Take away 20 again is 50. Take away 24, again I'm doing this in my head, but let's try and do this, use the call subtraction. So I got up to 50, and take away 24, because you don't want to mess up at this stage, you might get a mark if you write this down. Subtracting 0, take away 4, we can't do that, so we need to borrow from the 5. So I cross that out, that becomes 4, and this becomes 10, take away 4. And then 4 take away 2 is 2. So 26 minutes is how much time she has left, and she spent all of that in the cafe. The other way is I could do 50 add 20 add 24. So I'll just do that really quickly to show you another way. 50, 20, 24. That's 94 minutes, and then I do one big subtraction at the end, which is 120 take away 94. This is again to check your answer is right. If you weren't sure that it was 26, do the same calculation this way. So we can't do 0 take away 4, so do the same thing. That becomes 1, becomes 10. 1 take away 9, we can't do that, so that becomes 0, that becomes 11. 11 take away 9 is 2. So it's another check for us to know we got the right answer. So part B is Eleanor got to the sports centre at 1:30 p.m. She had asked her friend to meet her in the cafe at 3. Did Eleanor get to the cafe by 3? So we need to look at our clock, if we've got one in the exam, or try and picture a clock. That's my favourite thing to do, is an actual round clock, not the digital ones. And we know that 1:30 p.m. is when she got to the sports centre. She spent 120 minutes at the sports centre. But we need to know how many minutes did she spend before she got to the cafe. What time did she get to the cafe? So let's try and work that out. So if she got to the sports centre at 1:30 p.m, let's add in the total numbers that we know she spent before she went to the cafe. And it's a good job that we actually did this addition, because our answer will come in handy. The answer to how much time she spent before she went to the cafe is 94. So we need to add 94 minutes to 1:30 p.m. So let's think about, how do we add that? This is a time and this is a number of minutes. So 94 minutes is the same as how many hours in minutes? Let's try and think about that. Well, we know that 1 hour equals 60 minutes. So we know that 94 equals 60 plus, I can't fit another 60 in, because then I would go over 94, but what's the remainder? So this is again a bit of calculation. You can either subtract, or you can just work it out in your head by counting up. So let's count up. 60 plus something is 94. Well, I know that if I add 10, I get 70, another 10, I get 80, another 10, I get 90. So I've added 30. I need to add 4 to get 94. So it's 34. Now this is just easier for me to then add to my time, because 1:30 p.m, if I add 60 minutes, that's the same as adding 1 hour plus 34 minutes. So I get 1:30, I get to sports centre at 1:30, add 1 hour is 2:30, and then add 34 minutes. Again, picture your clock. If I'm at half past, if I'm at 2:30, I add 34 minutes. If I'm at 2:30 and I add 34 minutes, I get just past 3 by 4 minutes. So I get to the cafe for 3:04 p.m. So the answer is, she actually doesn't get to the cafe by 3, she's late by 4 minutes. So we need to answer our question by saying yes or no. No, she gets there for 3:04 p.m, which is 4 mins late. Okay. Question 13. The composite bar chart shows information about the number of people living in a village. So there's children, there's women, and there's men, and they're split over 3 years. 3 different years. Obviously this is 20 years as a span. Write down the number of men living in the village in the year 2000. So I'm not reading too much on this graph just yet. I want to go to the question and then try and find the answer by looking at the graph then, once I've read the question. So let's go straight to it. We need to look at the year 2000, so that's this bar. We need to write down the number of men. So I'm looking at my key. Men is the dark shaded square. So I need to count how much this is worth. So this will be a bit small, hopefully you can still see, but if my axis here is saying that this is 100 and there's 10 squares, I just do a simple calculation in my head, which is 100 divided by 10 is 10. So each mini square is worth 10, and that will help me count how many men there are. So I need to count up until the line for the men finishes. So that gets me 1, 2, 3, 4, 5, 6. So the answer is 60 people are represented by men in 2000. Find the number of children living in the village in the year 2010. So very similar. You go to this bar this time, 2010, and it's children. So find the colour for children. That is a bit harder now because it's not at the bottom, so I can't just count up from 0. I need to see how many 10s are in this portion. So that's 1, 2, 3, 4, 5. 5 squares worth. I know 1 square is 10, so 5 times 10 is 50. For the people living in the village in the year 2020, find the ratio of the number of children to the total number of men and women. So this seems a bit harder. It's 2 marks, but it's telling you where to look. So it's the third bar, and it's giving it, it's telling us to give our answer as a ratio. So instantly I know that my answer is going to have these 2 dots in for when we're talking about ratios. And the left-hand side is going to be about the number of children, and the right-hand side is going to be about the number of men and women. And the way that I know that is because the way that the question is written is the order of your answer. So when you see this 2, that is basically your cue to do these 2 dots. And I need to write the number of children there and the total number of men and women. So that is in bold. It's helping us actually that we need to add some numbers there. So let's have a look. How many children are in 2020? So do the same thing I did for this. I have to count how many 10s or how many squares that there are. 1, 2, 3, 4, 5, 6, 7, 8. So that's 80 children. So that gives me my left-hand side. And then I need to add up my women and men. Now I could just add every single square, but this is actually quite easy because I can count from 0 for this one because it's men and women are these 2. So I just need to see how tall is this portion, men and women, and I can just read off the graph from the left and I know that's 200. So my answer for the ratio is 80 to 200. Now it doesn't say simplify the ratio, so I could write that as my answer. It is best practice or convention to simplify. If we did have to simplify, like only if we did, how we would quickly do that is we get rid of where there's a 0 on both sides. So I get 8 to 20. And then I just try and half and half until you can't half anymore. So you get 4, 10, 2, 5, and nothing goes into both 2 and 5. So that would be my simplest ratio, but I don't think the question's asking for it, so you can just write these 2, I believe. Question 14. Jenny drives down from London to Swindon at an average speed of 54 miles per hour. She drives for 1.5 hours. Work out the distance from London to Swindon. Okay, straight away I'm going to draw my favourite triangle. And the way I remember it is just the word dust. D-S-T. And if I need to work out the distance, I just cover up that D. And that means I need to do speed times time. So speed times time. We've been given those 2 values in the question. So the speed is 54 miles per hour. And the time is 1.5 hours. So you could write 1.5 and it's not 1.3, which a lot of people make a mistake on. Half an hour is 30 minutes. So people think it's 1.3, but it's 1.5. But I'm going to stop here because this is quite hard to do when it's a non-calculated paper. So this is good to remember for questions overall. But because we don't have a calculator for paper 1, there's another way that we can do this, which is a bit easier. We know that 54 miles per hour is how much she drives. So if the time is 1.5 hours, we know that there's 1 hour equals 54 miles. In half that time, so half an hour, we just need to half 54, which is 27. And then if I want to get how much she's driven in 1 hour and half an hour, 1.5 hours, I'm going to add these two numbers up. So 54 plus 27, 4 and 7 is 11, carry the 1. 5 add 2 is 7, add the 1 is 8. So it's 81 miles. If you do know how to do 54 times 1.5, it might be a similar way in your head, but this hopefully makes sense for an easy time, like 1.5. And it makes you have to avoid using decimals and writing 1.3 incorrectly, which would lead you to the wrong answer. Okay, Alexi is using a map. The map has a scale of 1 to 25,000. On the map, a road has a length of 6 centimetres. Work out the length in kilometres of the real road. So what this scale means is when you have a map, it's not real size. So 6 centimetres distance on a map means a lot bigger in real life. And the scale is 25,000 times bigger. So 1 centimetre on a map is actually 25,000 kilometres. So we need to basically, what I do is I write the ratio again in the question. And this is basically saying 1 centimetre equals 25,000 kilometres. I put the units in, which makes it easier for me to understand. And now I can see what I need to do for 6 centimetres. So underneath it, I'm going to write 6 centimetres. And I need to ask myself, how do I get from 1 to 6? And it's going to be a multiplication or a division. I multiply by 6, so don't say add 5. These types of questions, you need to think about scale. And we've done something to 1, we times it by something, which is 6 to get 6 centimetres. That's kind of easy. But the hard bit is when we have to do the exact same to the right-hand side. And we don't have a calculator, remember. So we need to work out what this is in kilometres and do some calculations.
Big. 150,000 centimetres.
Let me just make some space. So we're going to do a trick what we've done before, which is kind of ignore the zeros for a second, because we're going to put them back in at the end. And that makes it easier for us to do. So 25 times 6, we can kind of do that in our heads. We can count up in 25s. I'm just going to write them down here. 25, 50, 75, 100, 125, and 150, and I'm going to stop there because that's 6 times. So 25 times 6 is 150, and then I need to add in these 3 zeros. So 150, then don't forget the 3 zeros, and that kind of makes sense because 1 centimetre was 25 kilometres, and it's going to be a tiny bit bigger, 6 centimetres, and that's the answer for how many kilometres it is in real life. Okay. This is around finding the coordinates of midpoint PQ. So midpoint means the middle of the line that is PQ. So PQ is the line joining points P and Q together. So first I would draw that. And then you have to work out what is halfway or in the middle of that line. It's just a fancy word for midpoint. To do that, you can just eyeball it. That's one way. So let's actually just see what we get when we do that. So we know that this is 3 across and then 2 across to get to Q. So that in total is 5, and halfway between. So let's try and eyeball it just to see roughly where it should be, and we can kind of see if we get the exact answer using the other way. I know that this distance from P to Q is 5. So on the horizontal axes, we know we need to half 5. Half of 5 is 2.5, so that's roughly about there. So we know that one point could be in this line here, but I need to know how higher up to go. So let's see how high we are from P to Q. That's 1, 2, 3, 4, 5, 6. That's a bit easier to half. Half of 6 is 3. So I count up 3 squares and I try and meet it to the distance that I kind of put a line against for 2.5 here. So let's actually write that. 2.5 was about there and 3 is here. So where do those two meet? This would be my x, I believe. And the coordinates for that are, let's go the x-axis first. It's minus, because before on the left was a 0, minus, looks like it's halfway, minus 0.5. So I can write that first. Let's hide that there. And then the y-axis is exactly 1, so that was easy for the y-axis. So my answer, I think, is this. And I think that actually is right because it's a 2-mark question. But if we were on a more complicated line, which didn't have easy to use squares to half, then there's a formula we can use, which seems very scary, but it's not. And I've written it out as simple as possible. So first, let's look at what the coordinates of P are. That's minus 3, minus 2. Here's P, minus 3, minus 2. And here's Q, scroll up again, 2, 4. So those numbers are really important because they're the ones I'm going to plug into my equation. Sorry, my coordinate formula, it's not really an equation. And I'm labeling them x1, y1, x2, y2. And that's because that helps me distinguish which x I'm talking about. Am I talking about the x coordinate in P or the x coordinate in Q? So it doesn't matter which way around I do this, but the formula is x1 plus x2, and I half that, and that makes sense because that's what we were doing in the first way. We were basically halving what we were getting as our heights and widths. So we have to halve the answer, and that gives us the x coordinate for the answer, and do the same for the y's. So y1, y2, I need to add them and then half them. So by doing that, I put the numbers in from the coordinates, and minus 3 plus 2 divided by 2 gets me minus 1 over 2, which gets me minus 0.5. That matches. And for the y coordinates, I always do one coordinate at a time also. For the y coordinates, I've got minus 2 plus 4, which is this minus 2, 4. And I half that. So minus 2 plus 4 is positive 2. Half that is just 1. 2 divided by 2 is 1. And that gets me my y coordinate, which matches as well. But this is not worth doing for 2 marks. I think you could roughly eyeball it, but it's a way to check that you've got the right answer. And this is really helpful when it comes to paper 2 and paper 3, where you will probably need to use your calculator to do harder calculations here. Okay. Question 16. Here is a quadrilateral ABCD. All the measurements are in centimetres. The perimeter of ABCD is 52. Work out the length of DC. So we need to know what the length of DC is. We know it's being called 2x. So really this is saying 2x equals what? And to get the answer to that, we need to know what x is, because when we times it by 2, we'll get that answer. So to get x, we have to basically solve an equation. And the equation is using the perimeter. We know how to work out the perimeter of any shape. We just add all the lengths of the sides. Even if we don't know what the lengths are, we know that we can add these algebraic expressions. And we know that they will add to 52. So that tells us that we need to form an equation. So let's just start at any point. I'll start at A because it makes sense. X plus 1 is what I'll write down first. And I'm going to add, because I'm doing perimeter, x minus 1. I could write it in brackets, but because we're adding, I think it's not going to change any signs. if it was subtracting, I'd have to put it in brackets, and then minus and a minus would be a plus, but we don't have that problem because we're adding all the terms together. Now we're up to 2x. And lastly, 2x minus 5. Now, I've purposely written the adds like very differently, just to make it clear like we've got all the 4 terms. It can help you keep track. And now we need to put what they all equal to. It equals to 52. We can just leave that for now, because we need to do a lot of simplifying on the left-hand side of the equals first. So to simplify, you have to collect like terms, and that just means all the terms that have an x in them, they can be added together. So let's just underline them. 1, 2, 3, 4, 5, 6. So I get 6x. And now I can add all my numbers up. I'll just circle them. And remember to include the minus when you do the circling. That's part of that term. And minus 5. So nothing is left out. And the pluses, we don't need to circle them there. They're just in between the terms. So let's do that, simplifying for the numbers. 1 minus 1 is 0. Minus 5, well 0 minus 5 is just minus 5. So I just write that again. And now you can see it looks more like an equation that we are normally used to solving for. So we did this on a previous question. We need to get x on its own to solve for x, and then we can put it back into the question it's really asking. So we need to try and get rid of what's happening to x. So we know that it's being subtracted by 5. So I'm going to do the opposite. I'm going to add 5, and I need to do that to both sides. I can't just do it to one. So minus 5, add 5 is 0. We already knew that. That's why we were trying to get rid of it. And I don't need to write 6x plus 0. I can just write 6x. And then 52 add 5 is 57. So at this point, there's 2 ways I could get my final answer. I could do what I just said, which is get x on its own. That's normally what we do. And then I plug that back into here, times it by 2 and get 2x. But I could also just find out what 2x is, and then I've got the answer straight away. And to do that, I need to see, how do I get from 6x to 2x? I'm either multiplying or dividing. I'm dividing by 3, because 6 divided by 3 is 2. And I have to do the same to this side, 57 divided by 3. And I might just go over here and do the bus stop method for this, because this is not normally in your 3 times table. We have to go a bit further in your 3 times table, past 12, for us to see what the answer to that is. So let's just do the bus stop method really quick. And this is how I do the bus stop method. I'm sure there's different ways. So how many times does 3 go into 5? Goes in once, and you carry the 2. How many times does 3 go into 27? It goes in 9 times. The answer is 19. So 3 times 19 is what gets me 57. And I can basically write my answer straight away as 19, because 2x is 19 centimetres, and that is exactly what this length is. DC is 2x. If I didn't do that way, and let's say that I solved the way I normally do, I solve for x, then we have to do something which is a bit more complicated, because remember, we don't have a calculator. So let's pick this back up. If we were at 6x equals 57, then to get x on its own, do the same sort of step. What do I do to get from 6 to 1x? This is the same as 1x, we don't write that. I divide by 6. So 6 divided by 6 is 1. And that means I need to do the same to this side. And this is a bit harder to do. I could do the bus stop method, but that kind of wouldn't work, because my first step, I have to put 0 and put the 5 then, and then it's just the same question again. So that doesn't really work. I can write it as a fraction and try and simplify. So 57 over 6, without a calculator, to try and simplify that. Let's try and half it. Okay, we can't do that because that's an odd number. We know 3 might be something that goes into it. So we have to do a division of 3, so I'd get something over 2, and then I have 257 divided by 3, which would mean doing the bus stop method again over here, so I'd get my 19, and I know 19 over 2 is basically the same as 19 divided by 2, which is halving 19, and that is 9.5, and that's how I get x without a calculator. So x is 9.5, and then I have to put it back into here. 9.5 times 2, well, I just double it back again, I get 19. And we already know that's the answer. So you can see how that would have added some time if you went straight from 6x to x, like we did here. But if you recognise that we need to work out 2x as a final answer, that's actually an easier calculation to do because you just need to divide by 3. Okay. There are only blue counters, green counters, red counters and yellow counters in a bag. This is a table that's not fully filled in yet. We know that there's a total of 100 altogether. I just like to write that instantly over there. It's a total. Ashin takes a random counter from the bag. Find the probability that the counter is not blue. So we have been given probability that it is blue. Well, we've been given a way to find that out. We know that there's 30 that are blue out of 100. So the number for the ones that are not blue is the rest. So that is 100, take away 30, which is 70. And we need to work out the probability, not just the number that are not blue, the probability that the random counter won't be blue. So it's going to be 70 over 100, which is the same as saying 7 over 10, which is the same as saying 0.7. It doesn't really say give your answer as a fraction or give your answer as a decimal. Okay, B, the ratio of the number of blue counters to the number of green is 2 to 3. I remember the way that the question is ordering this is important because I can basically write blue dot dot green, and dot dots are because of this 2, is 2 dot dot 3. That's the way to kind of remember which number is which. Work out the number of green counters in the bag. So we need to use the number of blue counters to help us here. So if we know that there's 30 blue counters, let's write that underneath the 2. And we need to ask ourselves another question, asking ourselves lots of questions. How do I get from 2 to 30? I times by 15. I need to do the same to this side. 3 times 15, we can kind of count up in 15s. 15 of 15 is 30. Add another 15 is 45. So 3 times 15 is 45. And if there's 30 blue counters, then we have 45 green counters. And that's the answer. Bradley says the number of red counters in the bag is the same as the number of yellow counters in the bag. Can Bradley be correct? This is basically having to work out how many are red and how many are yellow. So we can actually use this table if we want to fill in what we know already from part B. We know that the remainder needs to be something that adds to 100 when I add them all up. So 30 plus 45 gets me 75, which means I've got 25 to split between red and yellow. So I'll just walk through that calculation because that's probably going to help me give my reason. 100 take away, what did we do? We did 30 plus 45. It's the same as doing 100 minus 75 equals 25. Now, this number 25 is important because remember I used the word split. If Bradley says that the number of red is the same as the number of yellow, that means I need to have a number that when I split 25 in half, I can write for red and I can write it for yellow, and I can't do that because you can't get a nice number when you half this. When I say a nice number, I mean a whole number, a decimal. If I half 25, I get 12.5. That doesn't make sense because how can I have 0.5 or half of a counter? So we have to have either two numbers that add to 25, but they can't be the same as each other. So this could be 1 and 24, it could be 2 and 23, it could be any mix, but they're not going to be the same as each other. But we do know they will add up to 25. So the reason is we have to say no. He can't be correct because when we split 25 counters remaining, we do not get a whole number. But any way that you think will validly explain that should get you mark. Okay, there is a lot of text here, so I'm going to do something which I recommend, which is kind of go to the last bit, work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. Okay, that seems quite hard, but we can go back to the question now and try and understand it a bit more. So our answer is going to be in a percentage format, so that tells us something to look out for. There are 240 cans of drink on a shelf. Each can contains cola or lemonade or orange, and they're written in a ratio 5, 3, 2. So straight away I'm just going to do my writing out of the ratio. C for cola, L for lemonade, and O for orange. And I'm just going to write those numbers underneath. Half of the cans of lemonade and a 1/12 of the cans of orange are removed from the shelf. And then you need to work out how many cola ones are left out of the total cans remaining. So to do this, I need to convert this ratio into numbers that are the actual numbers of cans on the shelf. And I can use that because I've been given the total number, which is 240. Currently 5 plus 3 plus 2, that doesn't equal 240, so we need to make it in a different format. To do that, we need to add the parts and then split 240 in that ratio. So step 1, I'll write the steps here, add parts. So 5 plus 3 plus 2 equals 10 parts. Step 2 is you divide total by parts, so total is 240. Divide that by 10 parts, and that just means I take off the 0, 24. And then step 3 is multiply ratio by your answer in step 2. That means I need to multiply my 3 numbers in this ratio by my answer in step 2, which is 24. So let's do that. 5 times 24, well, 24 times 10 is 240, and 5 is half of 10, so I need to half my answer that I just did. Half of 240 is 120. But if you were struggling to do that in your head, then just do your multiplication on the right. So 5 times 4 is 20. 5 times 2 is 10. I add the 2, you get 120. So that's just a quick way. Don't forget your dots. 3 times 24, that's a bit easier to do, but let's carry on using this method as practice. 4 times 3 is 12, carry the 1, and 3 times 2 is 6, add the 1 is 7, 72. And 2 times 24, I just need to double 24, which is 48. And as a final check, these 3 should add up to 240, so if you want to check that, like in your exam, just see if they add up to 240, and they will. Okay, so now I can look at what this part of the question says. So all I did was put the ratio in a format that works. Half of the cans of lemonade let's just look at this first part for right now. Half of the cans of lemonade are removed from the shelf. So we know that there were 72 cans of lemonade. Half of them are removed. So let's just write this now. Removed from shelf. So something has happened. Put our dots in. 72, half of that is 36. Another way to do that also is the bus stop method, if that's hard for you to half. 2 goes into 7 3 times, carry the 1, 2 goes into 12, 6 times, 36. Okay, so we tick that bit. A 12th of the cans of orange are removed, so orange is O. We had 48, 1/12 of them are removed. So 1/12 of 48 is the same as doing 48 divided by 12. If you didn't know how to do it by division method, we can always just down here do 12 plus 12 is 24, plus 12 is 36, plus 12 again is 48, that's 4 times. So 48 divided by 12 is 4. So that's how much, and by the way, we're going to write 4 here? No, that's how much were removed from the shelf. So 1/12 of 48 was 4, and that means 4 were removed from the shelf. So 48 take away 4 is 44. And we don't get told anything that happens to the number of cans of cola. So let's just keep that the same number. So now we have a new total, right? Because 2 of the numbers have changed. That new total, let's work it out. 120 plus 36 plus 44. 6 add 4 is 10, carry the 1. 3 add 2 is 5, add 4 is 9, add 1 is 10, carry the 1, and we get 200. So our total number of cans on the shelf was 240, now it's 200. But the number of cans of cola has not changed. So let's try and write that as a percentage. That's what the question is asking for. So we know that cans of cola is 120 out of 200. Let's try and simplify it to a fraction that is very easy for working out percentages. I'm just going to put this in a box so it doesn't get confused with the other working out. I'm going to write this over 100. Now that's not the simplest way to write it, but it's the easiest way for me to quickly write the percentage. So I got from 200 to 100 by halving. So I need to do the same, divide by 2. I need to do the same to the top number. And 120 divided by 2, half that is 60. So my answer as a percentage is quite easy to work out now. 60 over 100 is 60%. And my pen is running out, so I'll be right back. Question 19. Write 500 as a product of powers of its prime factors. I love these types of questions. I think they're quite fun. I'm also back with a blue pen, but in your exam you need black, just a reminder. So we need to write 500 at sort of the top of a tree and kind of leave enough space. We've got a lot of space in this paper. So we need to ask ourselves, what prime numbers are factors of 500? Now the easiest one is to try 2. 2 is a prime number. It's the only even prime number. And we know that 2 does go into 500 because 500 is even. And we just need to know what the other factor is. So 500 divided by 2, if I halved that, I get 250. And I kind of keep going until I have to change to another prime factor that's not 2. So 2 again, times by what? Well, 250 divided by 2. I halve that, I get 125. And I can't actually divide by 2 anymore because now I've got my odd number. But I do know that 5 goes into this, and is 5 a prime number? Yes, it is. In fact, let me just list them out here. 3, 5, 7, 11, and so on. Okay, so 5 goes into 125. Now you can just count up in fives. 5, 10, 15, 20. Let's write out. So that took a really long time. So I want to do that just so you know you always have this option. You basically have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So now you know it's 25. It's kind of it's a calculation that you kind of will always know. 5 times 25 is 125. So if I didn't have time to do that, then one other way to do it is try and think of the biggest number in your 5 times tables that you do know. So 5 times 11, that's an easy one because 5 times 11 is 55. So already here you know that this is the 11th term. And then you don't have to write out any of this, you can kind of just write 55. And then you can start adding from 5 from there. It kind of shortens your time a bit. So you count from 11, 12, 13, 14, you get to the same answer, which is 25, but there's less writing out to do. Okay, so now we're at 25, and the only 2 factors that are prime that goes into this are 5 and 5. And I stopped there because I reached prime factors for both of my numbers. And now I just circle all of them just to be really clear that these are the ones that are prime. And I basically have to collect them so that they make sense in this format, product of powers. So how many 2's do I have? I've got 2 times 2, and that's the same as writing 2 squared. And then how many 5's do I have? I've got 5 times 5 times 5, which is the same as writing 5 cubed. And I just multiply them, that's what it means by product of powers. And that's the answer. I ran out of space, but that is what I would write there. Sometimes people forget to do the powers and they write 2 times 2 times 5 times 5 times 5. That is going to give me 500. That's correct, but it's not written in powers, so you need to write it in this format. But sometimes writing it like this first helps, and it can also be a way to check that you've got the right answer. But I wouldn't do this because it's not calculator paper, so checking this works is going to spend some time, which you might not have for the state of the paper. Okay, this is a fraction addition, and the number 1 rule of fraction addition is you can only do this when the denominators are the same, and then it's much easier to do. So let's try and get the denominators to be the same as each other, common denominator, and then add them up, and then just make sure that our answer is a mixed number in the format. So I first like to change these into an improper fraction, and there's a acronym I use called MAD, because they just get me so angry. So let's start with this fraction. So 1 3/5. So M stands for multiply, and that means I do 5 times 1. So let's write a little multiply there. And then I need to add, which means add the 3. So 5 times 1 is 5, add the 3. It's a bit out of focus, there we go. 5 times 1 is 5, add the 3 is 8. And that becomes my numerator. And then the D stands for denominator, and it just means you put the same denominator here, 8/5. So hopefully that is helpful. If you normally do this another way, this might be easier to remember in your exam. So that's 8/5, so I'm just going to write that here, plus, and then I need to just do the same thing for this fraction, so let's stop here, 2 1/4. So M means multiply. Also, I just like to have the answer ready like this. It just helps me remember what I need to do. 4 times 2 is 8, plus the 1 is 9 over 4. So that's my two improper fractions, and to get them to be the common denominator, I need to see what's in the 5 times tables and what's in the 4 times tables. And the first number that comes to mind is 20. And the way to get that, a bit of a cheat, is just do 5 times 4. Just do the denominators times each other, and that is going to be a common denominator. It might not be the smallest common denominator, but it will be a common denominator that you can use. Okay, so that is my answer, half of it. How did I get from 5 to 20? I timesed it by 4. So I need to do the exact same to 8. Remember, whatever I do to the bottom, I need to do to the top. Whatever I do to the top, I need to do to the bottom. So if I did 5 times 4 is 20, I need to do 8 times 4. And if I know my times tables, that is 32. And then you ask yourself the same question for the second fraction. I got from 4 to 20 by timesing by 5. And then that means I do 9 times 5, which is, knowing my 5 times tables, 45. And now it's so much easier to add these up because they are the same denominator, and I can just add these up in my head. So if I just did column addition, 5 add 2 is 7, 4 add 3 is 7, and it remains under 20 in the denominator, sorry, over 20. Do not add 20 and 20. That is the number one rule, is the denominators have to be the same, and the numerators are what you can add after that. It stays as 20. Okay, now we need to give our answer as a mixed number. So we need to convert this back to a mixed number by doing, it's not a nice acronym like MAD, but we need to say how many times does 20 go into 77? And we can count that in our fingers. 20, 40, 60, it can't go to 80 because that takes me above 77. So 20, 40, 60, that's 3 whole times. So 3. And get my denominator ready, that stays the same as well. And then I need to work out the remainder. So where was I? I was 20, 40, 60. What's the remainder from 60 to 77? That is 17. So that becomes my numerator, and that's my answer. I'll write it again. 3, 17 over 20. So hopefully this acronym is helpful for converting it to improper, because that's the easiest way, I think, to then get the same denominator. Okay, so part B is 2 marks as well. We need to show that this division equals 4 over 9, which is quite a nice question because you will definitely know if you've got the wrong answer if it doesn't equal 4 over 9. So we need to work this out, and hopefully it equals 4 over 9. So division is another acronym that I have, which many people will know. It's called KFC. It might ring a bell. And this stands for keep, flip, change. And I'll just go through the steps right now. So let's start with our mixed number. We actually can't work with this. We need to do something to it. And I'm going to go back to MAD here. So let's first convert this to improper, and then we can use KFC. So just forget that for a sec. So let's write this out. 2 equals, okay, multiply 2 times 3 is 6, add the 2 is 8, and denominator is 3, 8 over 3. Okay, I'm going to write my division out again. So this division is, stay over here, 8 over 3 divided by 6, and 6 isn't a fraction, but I can make it into a fraction quite easily by just writing over 1, because a fraction really means 6 divided by 1, which is 6. So we normally don't write this dividing by 1, but to make it easier for the KFC method, I'm going to write it as a fraction, because dividing by 2 fractions, dividing 2 fractions together is easier to do with KFC. And this is where we apply KFC. So K means keep the first fraction, so equals 8 over 3. flip the second fraction. So I need to flip this the upside down way. So it becomes 1/6. And you might be thinking, well, there's this gap there. Am I going to put a divide? No. We change, so C is change the sign to be multiply. And now it's super easy to do because we love multiplying fractions. This is the easiest calculation to do with fractions. You do 8 times 1 is 8, 3 times 6, and you can change denominators here if we're not adding. 3 times 6 is 18. So if I look at my answer and I just compare that with 4/9, I'm worried because it's not 4/9, but don't worry, we can simplify this. And if I just simply half both these numbers, 4/9 is the answer. So that's the working out to show that that division that we did got us 4/9. So first we converted it from a mixed to an improper fraction, and then we applied KFC. Okay. So I don't know if you can see this clearly, but there's powers on the 2's here. Let that zoom in. Wow, they're really small. Okay, 2 to the power -5 times 2 to the power 8, all squared. So that whole expression is in brackets and we're squaring that whole expression. So we need to simplify that and give our answer as power of 2. So we need to remember our rules for when we are working with indices and doing calculations with them. So let's say we have x to the power a times x to the power b. The answer is x to the power a plus b. So we add the indices when we're multiplying here. So let's just use that first. So I'm going to simplify what's in the brackets, so spread that out a bit bigger. So I need to add these powers up, so -5 plus 8. And just picture your number line. -5, you can do it on your fingers. Add 5, I get to 0. Add another 3, I get to 3. And I've added 8. And that means that we have a simplified expression in the brackets, and we're still having to square that. So now we need to use another rule. Just put that in a square. Let's put the second rule here. So when we have something like this, so x to the power a, and that's all to the power of b, the answer to that would be a times b. So we need to do 3 times 2, which is 6, and that is the answer. So remember, when you work out 2 cubed, don't put that as your answer. You have to do the squaring, so don't forget that. Question 22. So this is multiplying decimals, and it looks quite hard for a non-calculated paper, but the trick that I use is count how many decimal places are in your answer, or in your question, sorry, and that will tell you how many should be in your answer. So 1, 2, 3 decimal places there, 4, 5, because there's 2 more here. So our answer is going to be, let's write it here, 0.1, 2, 3, 4, 5 spaces would be in the answer. And to know what to put in these 5 spaces, you have to do one calculation, which is the numbers that are in the question, 4 times 32. So we can do that using column multiplication. 4 times 2 is 8, 4 times 3 is 12, so I get 128. The answer isn't 128 though, it's going to be a decimal, and we know that there's only going to be 5 decimal places, so I'm going to put 128 as the numbers that finish it off, and then I fill the gaps with the zeros. And that's the answer. I'll just put it here. Okay, this again looks like a lot of text. Let's just go straight to the end question. How many Model B cars the factory should make next year? So we know that 15 people out of 80 people that were asked what they'd be most likely to buy, said they were most likely to buy B. So these are the key numbers that I think I need to use. So we know that when 80 people were asked which of these four they would be most likely to buy, 15 of them said B. So 15 out of 80 is like the proportion. And we know that, okay, there's not going to be 80 cars now, there's going to be 40,000 cars. So I'm just going to write my new denominator as 40,000 cars, and this is what I need to find, which is my new numerator, my new number for B. So that will be my final answer. It's only 2 marks, so it kind of tells us we're on the right lines. So to get from 80 to 40,000, that's quite a hard number. I need to times by something, but what do I times by? It's quite hard to figure that out without a calculator. But what can I do to this? I can simplify it. So let's try and simplify that into something that is a denominator, which easily tells us what I need to times it by to get 40,000. Now this might seem like impossible, but I'm going to half this fraction, and you normally don't do this because that's not how we simplify, but for this calculation I just need to get this in a format that helps me get this number. So I'm not going to simplify this for an answer, it's going to help me get the answer. I'm going to half it. Half of 15 is 7.5, and that is my numerator. And it's a bit weird to see that as a numerator, but it is correct. Like if you put 7.5 divided by 40 in your calculator, it would give you the same answer as 15 divided by 80. And the reason why I'm keeping it like this, I'm not going to do any more simplifying, is because when I try and see what I need to do to this to get 40,000, it's very clear. I've just added 3 zeros, which means I've times by 1,000, because that's 3 zeros. And that tells me my answer is going to be 7.5 times 1,000, whatever that is, will be my numerator. I'm not going to write the answer straight away because I think this is actually quite a good calculation to practice. It is hard to do this without a calculator if you're not used to it. There's different ways to picture this calculation. You can either move the digits to the left because the number has to get bigger, or some people move the decimal places to the right. I like moving the digits, and in my head that's actually what I picture happening. So the answer to that is so I've just written a few spaces. This might not be correct, but it helps me picture what to do. So 7.5 is what I start with. Then I need to move it by 3 places because there's 3 zeros. So the 7 was there, and 1, 2, 3, now the 7 goes here. And the 5 was there, 1, 2, 3, now the 5 goes there, and then fill the rest in with zeros. And 7,500.0 is just the same as 7,500. And that's basically the answer, 7,500, because that's my new value for B. Okay, Bruce Wine writes down 3 numbers A, B and C, and they have different ratios given. A to B is 1 to 3, B to C is 6 to 5. Find A, B, C. So we kind of need to merge these two into one single ratio. And the way we do that is we have to see what's common in both of them, what's got the same letter in both, and it's B. So to get A, B, C, I need B to be one number. Like, am I going to pick 3? Am I going to pick 6? It doesn't work. The number for B has to be the same number in both ratios. So I need to change one of the ratios to get it to have the same value for B. So if I look at my values for B, I've got 3 and I've got 6. And if I multiply 3 by 2, that also becomes 6. Remember, I have to do the same to the 1. So let's change this ratio, that seems easy to do. I could half the 6 to get 3, but then I have to half the 5, and that gets me decimal, and I don't want that. So this becomes 2 dot dot 6, and this just stays the same. And now the b's are the same as each other, so I can just fill in my ratio underneath. 2, 6, 5. Okay, express a as a fraction of the total of the three numbers a, b, c. So this is actually quite helpful because it's telling you what to do. We know our answer needs to be a fraction, so that helps me out. And the denominator is usually what it's out of. In a ratio, we just add the parts. So 6 and 5 is 11, add 2 is 13, and a is 2. So I put that as my numerator, 2 out of 13. Emma writes down three numbers, m, n, and p. N equals 2m, p equals 5n. Now, these are equations, but because it's all part of the same question, it is actually about ratios, and we're actually asked to find m dot p. So we need to kind of rewrite these equations as ratios. So the way to do that is, let's start with the first one. We know that if n equals 2m, that means if m is, let's say, 1, 2 times 1 is 2. So we get, let's just write nm. When m is 1, put that back in, and what happens to n? It becomes 2. And that you can do for any number for m. So when m, oops, just lost focus there. Yeah, here we go. Let's try it with 10. If m is 10, 10 times 2 is 20. And that is double 10. So this ratio makes sense. Let's do the same with p. And let's do when n is 1. So 5 times 1 is 5. So let's say if n is 1, p is 5. Let's try it with 10. 5 times 10 is 50. And 50 is 5 times bigger than 10. Okay, so similar to part A, we now need to write m dot p. We need to merge these two. So we're actually going to give 10 n m p, and the way we do that is we need to have our values for the one that's common in both be the same as each other. So up here it was b. We need to make b the same as each other. Here we need to make our n's the same as each other. So we can do the same thing we did before. N is 1 here and n is 2 there, and it's easier for me to just times this whole ratio by 2. So then I get my new ratio as 2 dot 5, and it's still p n. Oops, so what have I forgotten to do? I need to times the 5 by 2 as well. So this is 10. So now I've got my number for n the same. N is 2 there and n is 2 there. So I'm going to use these two ratios to fill in this final one. So n is 2, m is 1, and p is 10. But the question is only asking about m dot p. So I just need to put that in my answer box. So that's the final answer, 1 dot 10. Okay, I think this is a penultimate question. So we actually are given the formula here for, the focus has gone. So we've given a formula here, and that kind of directs my attention quite quickly to this. I'm then going to find what is my force and what is my area, because I know quite quickly I need to work out the pressure. So my force is P for pressure equals 10,000 newtons. That's my force. And the area is not given to us, but we get given the numbers to work out the area. So I need to work out the area first. And the way I do that for a rectangle is I do base times height, which is 4 times 2, which is 8 meters squared. I'll just put 8 there. And, oh, I've written 1,000 is 10,000. To work this out, I can simplify the fraction. I don't have a calculator, but I can half both these numbers because they're even. So I get 5,000 over 4. I can half again to get 2,500 over 2. I can half again to get 1,000. Half 500 is 250 over 1. And that is the same as just 1250. Last question. This is an inequality. So it's saying 5x, I don't know what x is, but 5 times a number, when I divide it by 2 and then I add 3 to the answer, that is going to be bigger than 18. So we just need to work out the value that x could take, or the values that x could take, so that our answer gets a number that's higher than 18. So kind of treat this as an equal sign. It doesn't really change our approach. We did this before, right? We need to get x on its own. So what's happening to x? Let's start from what's closest to the equal sign, or in this case, the greater than sign. So we're adding 3. We want to undo that. We want to do the inverse. We're going to take away 3, but we have to do it to both sides. So let's start with this side. Plus 3 minus 3 is just 0, so I kind of get rid of that. And I'm left with 5x over 2 is greater than 15. Then I need to look at what's happening to the x. Well, we're dividing by 2, so let's do the opposite of that. It's times by 2. Do it to both sides. So I get 5x over nothing, because that cancels out. And 15 times 2, double that, is 30. And then last step, we're nearly there. What's happening to the x? It's being multiplied by 5, so I'm going to do the opposite. I'm going to divide by 5 on both sides. So I get x on its own, because dividing by 5 cancels that 5 there out. And 30 divided by 5, well, let's just do 5, 10, 15, 20, 25, 30. It's 6. So x needs to be greater than 6 for this whole inequality to work. Factorise this expression. As soon as I see the word factorise, I put this in, especially because it's x squared, so it means just 2 double brackets. And I put my x in there, and that's kind of halfway to answer. And then we need to ask ourselves, what 2 numbers, when I multiply them, I get 9, and when I add them, I get 10. So let's start with finding the factors of 9. You've got 1 and 9, and you've got 3 and 3. Now let's choose the pair that when I add them, I get 10. And the only one that gets me 10 is this pair. So that means 1 and 9 are my 2 numbers to put into these brackets, and I can just put them in any order because we are adding, so minuses aren't something we need to worry about. Doesn't matter which way we add, we get the same number, so I can put 1 there, 9 there. Would work if I put 9 there or 1 there. And that's the answer. So step 1 is always look at this term first and see what my factors are for that term, and then do a bit of an addition test here and see what gets me the middle number.